We're going to talk about correction of an oblique plane angular deformity. Important things are, there is only a single deformity, it just happens not to be in a radiographer's plane. There is a point where that bone looks completely straight. And if I turn it through 90 degrees and do the same, there's a point at which it looks very bent. Yeah? And if we take an AP, it's a bit bent. And if you take a lateral, it's a bit bent. Okay? But there is only one bend. It's just not in the radiographer's plane of interest. Okay? Now, because I'm a decent bloke, I've already done your homework for you. All right? When you measure your bone, you will find 15 degrees of apex lateral deformity. You will find 25 degrees of apex anterior deformity. I've even drawn you a foot because it's a left foot. All right, so those of you that were drawing the right foot from yesterday afternoon's lecture will have to turn your paper over. Okay? 25 degrees apex anterior, 15 degrees apex lateral. Draw this out on the graph. There's your resultant. And that comes in at 30 degrees, and it will be 60 degrees behind the true lateral. Okay? So if you think about it, it's very similar to the example we used yesterday, except it's the opposite side and it's pointing in slightly a different direction. But this is very much the same sort of thing as we did with the goniometer yesterday. All right? In the interests of speed and time, just because I want to talk to you through this and then let you get on with it, I've done a bit of pre-building. So there is a proximal ring couple, which is a ring and a 5/8 ring, and an identical distal couple, which is two rings. And one of the things you'll notice is if you look at where the rods are in the rings, they are evenly spaced. So same size rings with the rods in the same space. Okay? That works because it means you're not wasting holes in the ring on two separate rings when it comes to joining things together. Okay, so that's the first bit of pre-build we've done. And the only other bit of pre-build, and those of you that ever had to do one of those WHO checklists before you operate, this is what I do while they're doing the WHO checklist, which is build some hinges. And a hinge is basically a threaded rod with a high profile male tightened onto the end with a nut and another nut down there. Female, sorry. Thank you, home. Thank you, home. So 4 of those. And that's just a motor for the back. You can do it with an extra one of those, but we'll talk about why I use this later on. Okay, so that's all the pre-build you need to be able to do. Okay, and as I say, you can do that while they're, counting the patients or whatever it is they do.
What is that motor? Is it hinge as well?
It is. I'll show you exactly what it is. Threaded rod, same size, which then has on it, bolted onto it 2 high-profile males, and onto the end of each high-profile male is a high-profile 90-90. Okay, and when we get round to fastening it on, the flat side of the 90-90s is what's going to fasten onto the ring. Okay. So the correcting rod hangs off outside the ring. Okay, you can do it perfectly well with an extra one of those. There is no reason you can't do it like that. I think it just has a small number of advantages. Okay, so there we go. Ordinarily, being where I am, what I do and all that, the frame for any tibial correction would have 4 rings and 10 Ilizarov wires, 10 wires. I'm given to believe you can use half pins. Right, I hear a rumour that says you can use half pins instead of all wires. And given that we've got an hour to do this, and that, given that you guys want to spend your time doing it rather than watch me doing it, we'll put some wires in, we'll complete the frame off with some half pins, just in the interests of speed, for my demonstrating it to you guys. Okay? Now, I've set this up right up here at the top of the stand, because that's where I work. A number of my colleagues have to work slightly lower down. Okay? But I've set it up here, and if you look at how your tibia is mounted in your jig, I've got it mounted so the proximal tibia is essentially horizontal. Tubercle pointing at the ceiling, patella will be pointing at the ceiling. Ignore what happens down there. Just look at the proximal tibia. Okay? The first thing I'm going to do is just drop in some wires. And this is when you remember that you did check the drill in the battery in the drill, and it is working. Okay, the reason I think it's really useful to put the patella vertical and the tubercle pointing at the ceiling and the tibia flat, just makes it really easy to put in your first wire. Okay? And your first wire, your proximal reference wire, is through the tibia, at the level of the fibular head. And if you look at it, parallel to the floor. All right, horizontal is an easy thing. Okay, so that wire is level of the fibular head, just through the tibia, parallel to the ground. And all we're going to do then is mount this thing on it. I feel like Fanny Craddock. Is anybody old enough to remember Fanny Craddock? No. She was a person, not a... I say, if you look at the couple that we built, it's basically a 5/8 ring, because I always use a 5/8 at the top of the tibia. And I've put this rod essentially straight down the front of the frame, because that lets you line it up on the tibia. If you look at that there now, it would be really nice if you could, Owen. Thank you. Wire bolts are... That's the one thing I didn't check. Don't do whatever you've got, whatever there is for now. Okay. That will do fine. One of those. And it doesn't matter how much time you spend doing this bit. Because the proximal couple is what the entire frame is going to hang on after a little while. Thank you. Okay. And just for now, I'll just do those nuts up finger tight, because what you want to check is that your rod, the anterior rod you put in your frame, is exactly parallel to the tibia. Mo, step to one side. No, not you. I want to call you Cariad, but that's just me being rude, because you're...
Very affectionate, yes.
Yeah, that do,
yeah,
is it?
Yeah.
Lovely. Squat down.
No.
We need this rod about parallel to the front of the tibia.
All right?
About there?
Yeah.
Okay. Leave that to hang there. And then...
The front or the back?
So
The front.
So you can't see the back. So
Drop it a little bit then.
yeah, so you can run your fingers. On
Drop it a little bit, distally.
We happy it's about there?
I would drop it a little bit. And a bit more. That's about right.
Okay.
capture it.
Are we still right there? It's the great thing about Mo, he's much better as a door than he is a window.
You've raised it again a little bit.
Okay, I'll drop this. Happy?
We good?
Yeah?
Almost.
Reasonable.
Give or take a couple of minutes.
That's fine. We can buy back a couple of mil. Don't worry. Is anybody in here with us at the dissecting room? Yes. When is it cheating?
Only when you're caught.
Good. Before that, it's called.
Ingenuity.
Thank you. Just nip these wires in a little. It's a quick question. It's not much to do with anything else. Does everybody use the tensioner for tensioning wires? All right, let's try another question. Does anybody not use the tensioner for tensioning wires, with the exception of Mr. Dennison? Oops. Fine. All right, just for the purposes then, I will. This one. We won't necessarily tension everything because somebody's going to have to take this to pieces later. And it won't be me. Okay. Now, before we tension this second wire then, seriously, where is this bar in relationship to the tibia?
It's just slightly anterior, so you need to just drop it a bit. There, that's
About there?
fine. Yeah.
That's fine. Still right?
Yeah.
Yeah or yeah?
Yeah.
That was a sort of Welsh yes, wasn't it?
Well, you kind of, when you're supporting the back, you keep pushing it up. It needs to drop a little bit.
Or the bone needs to rise up a
Or
little
the
bit.
bones rise up, yeah. It's only minimal.
What are you doing?
How better? Okay, right. Don't mind me. Right. Are we good?
Yeah, that's good.
Yeah, you steer
That's
well
good.
clear of him. He's just trouble. Now, we all accept that at some point you put in a lot more wires and all those sorts of things. Okay? But if you think about it, you're basically being my lateral view, right? And you've said those two rings are exactly parallel to that tibia, the proximal part of the tibia, okay? And if I stand here and look down, and I be my own AP, that rod is exactly parallel to the tibia. So those two rings, that couple, are the proximal tibia in space, right? That's it. We need to complete it out a little bit more, but there isn't much else to it than that. Let's get these out before somebody loses an eye.
That's happened.
I'm just going to chuck the sharps underneath. Now, remember what we said earlier? When you look at this thing, there is a point at which you can make it look straight by twirling around the image intensifier, which means there's also a place 90 degrees away from that where it is maximally deformed. Yeah? We agreed? You can do exactly the same thing with this thing now. Right? All we're going to do is just rotate this bone until you, as my lateral projection, tell me the bone looks straight.
Okay. Yes.
There. That bone looks straight to you.
Yeah.
Okay? So if we leave that there for now, you think, you're telling me, it's one of those let go things, isn't it? I'll take your word on it, that as you take what is basically a lateral projection with this leg externally rotated, it now looks straight.
Yeah.
I don't know. We don't want fairly straight.
Straight.
It's straight.
Yes.
Good. Therefore, if I stand here and do an AP,
Yeah.
which I can, right, I should now be looking into the maximum deformity.
Yeah.
Yeah? Now, remember we said earlier, when we're doing hinges and osteotomy rules and all those sorts of things, work out where you want the hinges to be in relationship to the bone you're cutting, to the wedge. Yeah? Remember we said that? If you're using hinges, if you put them right on the convex border, the bone will come straight and not lengthen. If you put them away from the convex border, the bone will straighten and lengthen.
Yeah.
And if you put them in the bone or on the concave side, basically you'll have to compress things to get it straight. We all agreed? Now, there we go. Can you stand still there and hold it there? No, seriously. Can I convince you then that as we look at this as an AP, if I was to put hinges here, the bone would just come straight. If I was to put the hinges down here, the bone would come straight and lengthen. If I was going to put hinges here, the bone wouldn't move unless we took some bone out. Yeah? Okay, so there should be one hinge exactly there where we can see it, and the other one wants to be right around the far side of the ring in exactly the same plane. So basically, somewhere down there, off the middle of that lens. Does that make sense? Okay? So we're going to put one hinge about there, like so. There, so it sits right on that border, right on the convex border, and the other one's going to go exactly around the other side. And obviously, if you do this with the intensifier, you can actually see the second hinge.
You just see them superimposed,
Yeah,
not as double shadow.
but there we go. I think that's about there. Okay. And so far, we've done nothing but stick 2 wires into this leg. So we've done nothing so far we can't walk away from. But that is basically the top half of the frame. What we need to build now is an identical bottom half of the frame, which is exactly collinear with that segment down there. So it lines up exactly the same in the AP and the lateral view as this one does in the AP. Okay. And then, just like we did at the top, we're now going to put in a distal reference wire. Which is going to be, just like the top one, through the tibia, to the tibia, at the level of the distal fibula, parallel to the ankle joint, and parallel to the ground. Okay. And I say parallel to the ground is a useful thing because everybody can see it. Okay, so there's that reference wire. Okay. Remember, the other thing we said we were going to do was to join this half of the frame to that half of the frame. Okay? And we know where that hinge is, therefore we know where this hinge is going to have to go, which is in exactly the same hole as it is over there, which is remarkably just where we've put that rod.
So it's
Isn't it always? Somebody was asking me the other day why I don't pre-build frames, and the answer is I'm not good enough at building them.
Yeah, I have to dismantle them again.
Okay? But we're going to have to do something with that rod there, aren't we?
We'll have to move it.
Yeah.
May not have enough time to finish it, so while you're doing it, can you start as
Yeah,
well?
that's fine.
Because that way it's easier.
Fine. We've got some homework to do. Do you guys want to get yourself to this far on?
Mm-hmm.
Thank you. And we'll have a tinker. Ohm and I can have a tinker with this frame up here and make it work. Okay, right. Now you're sort of catching up. All right. We've put an identical hinge in an identical position on an identical ring just below the focus of the deformity. And we're going to bolt that together up there. Okay, and if you look, there's something exactly similar directly behind that where you'd see it on the intensifier. Okay? And we said that this needed to be an exact model of this deformity in this bone. And I've got this turned round so I can see 30 degrees, and I can see 30 degrees of deformity in that frame. Okay? So all we need to do now is fasten this wire. So the distal reference wire, we're just going to fasten on this distal ring. Snip round and make sure everything's fairly tight. 4mm washers somewhere, I've seen them.
Yeah.
Oops, today. Just like real. And again, we're not going to tighten this wire up too much yet, just in case we need to move things. Just give it all a bit of a nip. Okay. So as I stand there now, that frame is bent 30 degrees as I look at it straight into there. Okay. And what we'll do is I'll just disconnect this and spin it round so you can see it. Okay. Because if we've got this about right, that rod should be parallel to the front of the tibia. Yeah? If I just roll it round so you can see it, that rod should be about parallel to the front of the tibia. Yeah? If I drop it all the way to there, that frame should be about straight as you look at it. Okay? Which means that if I turn it to there, the hands on the clock should say 5 to 12. That should be 30 degrees as you look at it in there. Yeah? Is that the way it looks? Because at some point you do have to trust people, I'm afraid. Yeah? Yeah? Does it look about right? Let's just put that in there. And in the interests of speed, we will hide some spanners. Those spanners. If we just nip up this bottom wire here, okay, and we'll just drop one more wire in here just so we've got enough stability in the frame to make it do what we need to do. You fast me that end down, mate. We're running out of nuts, aren't we? And again, we'll just nip that up just for form's sake. Okay, now, there are two ways of working out where we're going to put the third hinge. One of them is you can simply count. Just count the holes from me to you, symmetrical as we go. The other way to do it, if you think about it, is if I hang that there, so that one hinge is directly above the other one, and if you were to sort of squint at those rings there now, the point of maximum convergence, the point where the rings are closest together as you look, should be halfway from there to there, shouldn't it? So I would suggest it's about there. Okay. So you get hold of this thingy. Same thing. Don't want they always just too long. There we go. Is that about the right place? It's about half. Is that halfway from one to the other? No. It's a very good point. At the end of the day, as long as they all end up the right length, then the bone will go straight.
you eyeball them basically where to put the motor
It's where the rings are closest together.
closest together.
Where the rings are closest together is the point of convergence of the frame.
Because the rings are mimicking the deformity.
Yes, exactly. So if you think about it, we have to all intents and purposes build a three-legged stool, one leg of which is adjustable. And three-legged stools don't wobble, but they do slope. Okay. Now obviously, when you're doing this for real, you'd put some more wires in or some half pins or whatever you're going to do. But that basically is the frame done, which means that scientifically, if we cut this bone and pull, it should all just go straight, shouldn't it? Now, like we were saying this morning when Badri was talking about techniques for dividing the bone, it probably doesn't matter a hang how you do this. But sometimes in these sawbone models, the plastic, the stuff for joining, is actually incredibly tough. So you can pull like mad and it won't move. Okay? Basically now, if we turn to our motor, that thingy down there, and start to turn it, and the frame will try and straighten in that direction that you can't quite see. And in theory, the tibia should then just come out straight, shouldn't it? About parallel, about straight. And here's the voodoo. This is like the grand reveal, isn't it? It's like pulling the rabbit out the hat. Is it really straight when you look at it in the other direction? That's what you're all asking. I know what you're thinking. Watch closely. Can I convince you? All right. So there we go. You're going to get taught this in the foreseeable future, Jim. All right. The big secret, the thing we don't tell you, there is no big secret. All right. It's common sense and basic principles.